In this video, we're going to take a look at section 5.7, which is on solving formulas for a variable. To solve a formula for a variable, isolate that variable on one side of the equation. We've done problems something like this earlier in the course. These are going to be a whole different level of formulas, but we've seen this situation before. You're given a formula, you want to solve for a particular variable, so you work to get that variable by itself on one side of the equation. That's how you're going to solve it. You move all the other variables to the other side. And the one piece of advice I had earlier in the course was treat the other variables as if they're just numbers. You can't really replace them with numbers, but you just do with them the same thing you would do with numbers that were in the same place. I don't know if that's going to be as helpful in this section. These formulas are something else. So let's take a look at a few examples. Solve n equals gs over g plus s for s, right? So we have a fraction. This is why it's in chapter 5, right? We've been dealing with these rational expressions the whole chapter. That's what we're dealing with here as well. It's a fraction. It's a rational expression. We're trying to solve for s, and it's made even more difficult by the fact that we have an s in the numerator and an s in the denominator. But either way, even if there was just one s here, we got to get rid of the fraction first before we're going to be able to, make any progress. So I would think of this n also as a fraction. Think of this as n over 1. And we can use the shortcut we talked about in 5.6, which is cross multiplication, right? Or this was in 5.5, excuse me. This was even further back, right? So in 5.5, we talked about solving equations. And in this case where you have one fraction equals one fraction, you can use the shortcut of cross multiplying. So we'll multiply the opposite corners together. We'll take n times g plus s. We're going to multiply those together. N times, because there's two terms there, I'm using parentheses, excuse me. And then we'll multiply these opposite corners together. We have 1 times gs, right? Which is just going to be gs, right? When you multiply by 1, that just stays the same. All right, so that wasn't too bad getting rid of the fraction. Now we will distribute the n into this parenthesis. So we have ng plus ns equals gs. So what we have to do here, we're trying to solve for s, and s is in two different places, right? It's here and it's here. So I keep thinking about what's my obstacle I need to deal with right now. So my first obstacle was the fraction, right? So we got rid of the fraction. My second obstacle was the parentheses. I can't solve for s while this is stuck in the parentheses, so I distribute the n. Gets rid of that obstacle. Now the obstacle I have is s is on both sides of the equation. I can't solve it for s while one is on the left-hand side and one is on the right-hand side. So what I'm going to do is bring this term with an s over to the right-hand side to join this one, so that all of our terms that have s are together. All right, so we'll minus the ns over to the right-hand side. And we'll leave the ng here because it doesn't have an s. So we'll have ng equals gs minus ns. And this is the critical juncture of this problem. And I think we dealt with this back earlier in the course as well, but maybe you forgot. We have s in two different places, and the way we're going to deal with that is to factor it out. And especially now that we've done chapter 4, factoring should be pretty fresh on your mind. And so hopefully you would think of this solution sooner rather than later. But it's a common factor, so we can factor it out. So let's continue up here. So we'll have ng equals, we'll factor out the s, and that's going to leave me with g minus n in parentheses. So we went from having two s's to now just having one s. So that's progress. And then to get that one s by itself, we need to get rid of the g minus n. It's being multiplied to it, so we will divide by g minus n. Sorry, that's kind of a funny looking n there. Let's try that again. All right, and so we'll divide by g minus n on this side as well. That cancels out the g minus n's because they're factors here. And so we'll have ng over g minus n equals s. And now it's solved for s. Be careful, this is another thing we talked about earlier in the course. When you're typing this in, variables are case sensitive. So in Math Excel, you have to type in capital N, lowercase g when you're typing this in. If you put lowercase n here, it's going to count it wrong. All right, let's look at another example. Okay, so this one we can't cross multiply, unfortunately, because we have two fractions over here on the left-hand side. So cross multiplying is out of the question. So we're going to have to go back to the old school way of solving these rational equations, which is to find the LCM, multiply it to both sides, and then simplify and go from there. All right. So to find the LCM, we have to factor everything. Well, these you can't factor these, so they are their own factors. S is the factor here, P is the factor here, B is the factor here. So we want to find the LCM of these three denominators. Well, we have to take each factor that occurs, and they're all different. So S is a factor, P is a factor, B is a factor. And we raise each one to the highest power that occurs. Well, these are all to the first power, so this will be my LCM. All right, so what we want to do next, the second step for solving a rational equation, is to multiply the LCM to both sides. Since the words are kind of in the way here, I'm going to rewrite the equation. 1 plus S, I said 1 plus S, 1 over S plus 1 over P equals 1 over B. That's our equation. And we're going to multiply the LCM to both sides. So remember, this was the way I started doing it on some of the later problems in 5.5. Just put parentheses around the whole equation and then multiply the whole equation by the LCM. All right, think of this as being over 1. We'll distribute, multiplying it to the left-hand side and to the right-hand side. So when we multiply it to the left-hand side, the S is going to cancel out. So again, I'll temporarily mark that out. So I'll be left with 1 times PB. Right? So I'm going to unmark it because I want a fresh copy of this to multiply to these other two. But we're going to have PB left over here. A fresh copy of this gets multiplied to the 1 over P. The P's will cancel out. And so we'll have 1 times S times B. So we'll have SB left over there. All right, so we have plus. We'll have SB left over on this one. Equals here. The B's will cancel out, and we'll have 1 times SP, so we'll have SP left over on this one. All right, so that's step 3, simplifying it. And then step 4 is to, solve this, and we're being asked to solve it for S. So we're actually in the same boat we were just in on the last problem. We have S on two different sides of our equation, two different sides. There's only two sides, but we have S on both sides, is probably the better way to say that, of our equation. And so we're going to move to get all of the S's together on the same side of the equation. So minus SB over to the right-hand side. So we'll have PB equals SP minus SB. And then just like we did on the last problem, we will factor out the S. It's a common factor here, right? We have S in this term, we have S in this term, so factor out the S. So we'll have PB equals, try that equal sign again, equals S times parentheses P minus B. And then we'll divide by P minus B to get S by itself. All right, so this one had a very similar ending to the first example that we did. The beginning was different, but once we got that initial result, it was just like the last problem. All right, so let's look at another example. So this one, pretty similar to the first one that we did, except instead of just having n over here, we have an actual fraction. We have c over k. But we're going to do this one the same way we did the first one. We're going to use cross multiplying to start this out because we have one fraction on the left-hand side, one fraction on the right-hand side. So let's take advantage of that shortcut. We'll multiply the opposite corners together. C times W is what we get for one result. The other result will be K times P plus W. So K times parentheses P plus W. And what we do with those two results, don't forget, if you're using the shortcut, you have to remember this little detail. You set them equal to each other. So I didn't really make a point of that with that first example, but I will see a lot of students on the test where they cross multiply and they get these results and then they don't know what to do with those results. So you need to remember you set them equal to each other. Otherwise, it's not worth doing the shortcut. All right. Then we'll distribute the K. And keep remembering is what I was going to say. Keep in mind, it's hard to tell, right? But this is a lowercase k. You can tell from the typing it's lowercase. From my writing, it's kind of hard to tell. Is that capitalized or is it lowercase? Because k kind of looks the same either way. So it should be a lowercase k, right? Keep that in mind as we go through the problem, because when you go to type it in, you have to make sure you have it in the right case. All right, so we have CW equals k times P plus k times W, right? And again, it's the same problem as the last two once you get to this point. We're trying to solve for W. It's on both sides of the equation. So the first step is to get all the W's to the same side of the equation. So this time it's a little bit different, right? But I think the better path this time is to subtract the KW over to the left-hand side. So this time we'll have our W's on the left-hand side instead of on the right-hand side, like the last two examples. All right, so we're going to get CW minus KW equals KP. And also that's a capital P. All right, so we'll just continue up here. Let's use a different color. All right, and then we'll factor out the W because it's a common factor in both of these. So I have C, capital C. All these letters are hard to tell, aren't they? They all look the same, whether they're capital or lowercase. Maybe that's the challenge for this problem, is not just, oops, I almost put a lowercase p, not just solving it, but making sure you remember the cases of each variable. And then to get W by itself, we divide by capital C minus lowercase k. Capital C, lowercase k. So my final answer, let me see if I can really exaggerate it here. It's a lowercase w equals lowercase k, capital P, over capital C minus lowercase k. I'll just kind of write it small. All right. And that's what we need to type in to Math Excel. All right. So I only have a couple more examples left. This one, again, looks a little bit different. Have extra variable in there, but it's going to probably run the same course as the previous examples. So why don't you pause the video for a moment, see if you can figure out how to solve this formula for C, and then resume the video to see if you came up with the right answer. All right, I'm going to think of this as h over 1. And then we will cross multiply because it's one fraction equals one fraction. So we're going to take advantage of that shortcut here. So I'll multiply the opposite corners together. We'll have h times c plus pr. This one's kind of nice because all the variables are lowercase, so we don't have to remember which one's capital, which one's lowercase. And then we'll multiply these opposite corners together. So we'll have 1 times pc, which is going to be pc. And then we set these equal to each other. Our next obstacle is we're trying to solve for c, which is stuck in the parentheses. So we're going to have to go ahead and distribute the h to get rid of the parentheses here. So we'll have hc plus hpr equals pc. All right. Now that we have our variables all out in the open, we can try to solve for c by getting c on the same side of the equation, right? So the next obstacle is c is on both sides of the equation, but we really want it to be on just one side of the equation. So I will subtract the hc to the right-hand side. So that's going to give me hpr equals pc minus hc. And then c is a common factor in both of these terms, so we'll factor it out. So we'll have hpr equals c factored out, and then p minus h left over in parentheses. And then the last step is to divide by p minus h. And so we get hpr over p minus h equals c. That's solving it for c. So I hope you had some success with this problem. All right, let's do the same thing for this next one. This is our last example. It's kind of like the second one that I did earlier in the video. This one I think is a little more challenging than the cross-multiplying ones. So again, pause the video, maybe go back and look at that example we did earlier that looked just like this, and see if you can work through this problem on your own. And then resume the video to see if you come up with the right solution. All right, so the first step is to find the LCM, because we can't cross multiply here. Sorry, I'm pushing this button on my pen, which makes me erase as I'm writing, equals, again, we would want to factor these, but these can't be factored, so that means they are the factors. B is the factor here, T is the factor here, M is the factor here. You take each factor that occurs, well, B is a factor, T is a factor, M is a factor. They're all different from each other. Raise each one to the highest power that occurs. They're all to the first power. And so that's my LCM, BTM. All right, so what we're going to do with that, I'm going to rewrite the problem down here so we have some room to work. I'm going over t if I can. Let's see. All right. And we will multiply it to both sides of the equation. So I'm going to multiply btm, let's go ahead and write my t's the same way, on to the whole equation, right? Which means I'm multiplying it to the left-hand side and to the right-hand side. Sorry, I didn't really like this plus sign that much. All right. Think of this as being over 1. We'll distribute it. All right. And what's going to happen, so let's see if we can do this without having to write anything down. When this gets multiplied to the first fraction, the b's cancel out. So without me having to cross it out, let's just mentally think of that. The b's cancel out. I'll have 1 times tm left over. So that's what I meant by not writing anything down. We'll just have tm. Equals, when these multiply together, the t's cancel out, and I'll have bm left over. Plus, when these multiply together, the m's will cancel out, and I'll have bt left over. All right. And then we're trying to solve, I almost kind of forgot what we're doing. Trying to solve for m, so now we want to get our m's to the same side of the equation, so I'll subtract this bm to the left-hand side. So all of our m's are on one side of the equation. We have tm minus bm equals bt, and then we will factor out the m. All right, so we're going to factor out this m here, so let's continue up here. Factor out the m, we'll have t minus b left over, equals bt still, and then to solve it for m, we divide by t minus b on both sides. Okay, so these cancel out, and we get m equals, see if I can write my b's a little bit better here, bt over t minus b. All right, capitalize b, don't forget that. So that concludes the video on section 5.7, which is on solving formulas.